of the same function, final function. What is useful is in automotive environment, where you can compare, for example, different typology of cars, for example, who use a different typology of fuel, but have the same function finally. Transport you from one side to another side. Here I represent to you three cars: Tesla car, Panda car, and Maserati. The first one on the left side, the Tesla, is an electric car. Panda is a utility car, and Maserati is a luxury car. With the three cars, you can go from Milan to Osuni, for example. You can do 1,000 of kilometers using three different cars. But when you buy a car, one of the left side, another one, this car is built from a producer who produced the car, and this car is composed by plastic, steel, glass, and other material. During the life of the car, what you do? You do manutention, typical manutention of the car. Using the car, you consume fuel or energy, electric energy, for example. When you develop a life cycle assessment analysis, you have to evaluate all the indicators, environment indicators, includes each phase of the life of the car. For example, how you produce the car, which are the material construction used, what are the raw materials. Using the car, you establish how many energy you need to transport you from Milano to Ostuni, for example. Or at the same time, what are manutention phases for one car or for the another one? To compare the free solution, you have the final purpose: transport you from one side to another side to a defined number of kilometers. Finally, what do you have? When the car don't work, finish its life, you demolish it. And so you can demolish the car and create and waste the total car, or you can separate each material construction used to create new material construction, new material for other cars. The life cycle assessment and the life cycle cost are two methods by which you can compare different solutions for an element, a car or building or infrastructure, by which you can develop the same function. And so life cycle assessment and life cycle cost is a comprehension method by which you can compare three solutions for the final purpose. The same is for a bridge, for example. This bridge this bridge is a bridge in London. It's the Millennium Bridge. Is in this case a steel building, a steel bridge. When you design a bridge, you can choose different solutions. For example, you can choose a wood solution, a steel solution, concrete solution, or in the past, stone solution. But the function will be the same: to help you to pass across Thames, for example, in this case, from the left side to the right side, from the center of London to the Docklands in this case. And so the function is helps people to pass across the bridge, the Thames, using the bridge. So in this case, what it happened? It happened that you can compare this bridge with other solutions. For example, to pass in the history, to pass from the left side to right side of the Thames, you have a different bridge. The history was built different bridge in the history of the Thames. You see here, for example, stone bridge plus steel bridge. Here another ancient bridge, and here the modern one. Consider these ones. Which is, if you want to build new bridge now, the solution, the much more ecologic solution, and much more people tell that. The wooden bridge is the ecologic solution. It's not true. If you see here in this slide, you have many bridges which are oldest than much more than 100 years. This bridge was built in 2000 year. And so, if this bridge is thinked to will be demolished in 50 years, the better solution, I don't know if will be these or the ancient ones. When you design a new bridge, for example, new building, new infrastructure, you can use the life cycle assessment method to compare different solutions for the same final function. For example, this bridge is much more ecologic, a bridge in steel, in wood, in stone. Depends the time of the durability of the bridge, for example, depends of the material on the material construction used, depends on the manutention phases needed into the life of the bridge, in this case, depends if people in its time, in the time of life of the bridge, can use this bridge each day or sometimes. If you choose finally the solution for the bridge, the steel version, what will be happen? Will be happen that this steel bridge will be protected using a paint coating or a zinc coating. If you consider paint, a typical paint, you have to replace the paint each 3-4 years maximum. If you use zinc coating, you have to protect this bridge, I think, each 30 years. And so, which is the solution, much more ecologic solution from the zinc coating to the paint coating? Maybe zinc coating will be the much more ecological because you have to replace the coating each 30 years. Useful is thinking that the zinc coating is a system with a much more height environmental impact. The idea is this, but if you divide the environmental impact in the year of durability of this bridge, is easy to think that the zinc coating is the better solution. The same method will be applied to a building. For example, this is another famous building, is the Shard designed by Zupiano. In this building, life cycle assessment, how it can be used? Can be used for different systems, for different opportunity. You have to evaluate the indicator which define the final function. For example, you want to evaluate this building for the material construction used. You want to evaluate the final solution in function of the manutention. You want to define the life cycle, the life cycle assessment to define the energy consumption, how you can resolve problems about the energy consumption. You can use life cycle assessment. I give it to you an example using this tower for example. How you can build this tower? We can build this tower using steel technologies, concrete technologies. Don't think wooden technologies, because the tall building has many problems. If you have little fire, become a big fire. With wooden solution, I don't know if it's better. And so you can compare steel solution to concrete solution for structures, for example. The same method will be used to define the envelope of the building, the exterior facade of the building. For example, using different typologies of glasses. In this case, you can use, for example, glass with 2 layers, 3 layers, using other typology of walls, maybe. Depends on the final function. For example, if you need the architect define that to have natural lighting inside of the building, you have to use glass solution. If the choice is this, you can use life cycle assessment approach to choose which one's solution is better to consume less, for example, or to have a solution which required less manutention during its lifetime. For example, if you compare two solutions, glasses with 2 layers, glasses with 3 layers, what it happened? Using 3 layers, for example, the building consumes 30% less than using a curtain wall with 2 layers. And so you can establish and create a model by which you can compare the two solutions. Solution 1, 2 layers, solution 2, 3 layers. But in the analysis, you have to insert the results of the energy consumption of this building in its life. If the life of durability of this building is 100 of years, you have to insert the energy consumption in 100 years using the first solution or using the second solution. In 100 years, how many times you have to change the exterior wall? 3 times. And so you choose a solution by which you have a guarantee for in safety that each 33 years you have to change the exterior facade, or you choose a economic solution by which you have to change the exterior facade each 20 years, for example. And so in 100 of years, you have to change the exterior facade 5 times, not 3 times. Yes, maybe the final, the last solution costs less than the other ones because you choose, for example,